Well, here we are with another of my fine collection of Heathkit IG-102 RF signal generators. This generator is in excellent shape, both physically and functionally. We've cleaned her up, we've lubricated and cleaned the switches. The cabinet has been painted nicely. Has a very new look to it, or at least a much more modern look to it than it did. We're going to put it through its paces. A couple things to point out. We have BNC connectors in place of the old button style connectors. This allows you to utilize the latest in cables and gator clip connectors and things like that that are available at cheap rates actually on eBay. This unit's capable of producing from 100 kilocycles up to 110 megacycles, and it does that in 6 ranges, A through F. We can do a continuous wave signal without modulation. We can add modulation either internally or externally. If we want to do it externally, we feed a signal in here and we can control the level of the external modulation from this position, or this potentiometer. If we want to take a look or use the audio frequency out, which this thing has about a 400 hertz tone that we can get out of here as well. And we can control the volume of that with this unit. We have a continuously variable fine attenuation control, and then we have a 3-level coarse attenuation. So with those 3 levels and this variable, you have considerable range and attenuation. So let's go ahead and hook this unit up, and we'll take a look at it on our oscilloscope, and we'll also take a look later at our frequency counter to verify the accuracy of the dial. Bear with me. Okay, well, we've hooked the generator up to our scope, and we're going to take a look here. Right now we are on band A. We start out at 100 kilocycles. This would be the outer band, and we are right on the 100. And as we can see from the oscilloscope, we can see the trace on the oscilloscope, and we look nice and clean at this signal. And right now, I also have the counter working. We are reading 100.8. We're set to 100, so we are 0.8 kilohertz off on the dial, which is pretty good for this vernier. We're going to go ahead and take her up mid-scale. I would call that to be about 170 kilohertz. That would be right about there on the dial, and looks like we're picking up about 172. But let's go ahead, we're going to go to full scale. Full scale would be 320 kilocycles. And there's our signal waveform at 320, and we are reading 321.4. Not bad. I'm going to go up a band. And at this point, see, I just switched the band switch here. At this point, we are on 310 to 1100. That's the second indicator inside here. So you want to go to the 31 on the dial, which would be about there. There's our waveform, looking good. And again, we're supposed to be 310, we're reading 311.1. If you were to figure the error out, that's 1 over 310, so about 1/3 of 1%, so 0.33%. Okay, let's go to mid-band on this. I'm going to call this 5500 on the dial. Looks like that's it. Here's our signal. There. Looks good. And we are reading 552.9, 553, 55. I am just slightly off to the left, maybe. Let's go there. 554.7, so if I'm calling my position on the dial right, then we're off like 0.3 out of 555, so not bad. And then 110 on the dial, I'm going to say that's it right about there. This is our signal, and we are reading 1078 instead of 1100s. And we'll take ourselves back down again. And this band is from 1 megacycle, so we want to read on the outer edge again. We're going to go from 1 to 3.2 megacycles following the outer range band. Here's our signal. Looking good. And we are 0.5 out of 1,000 hertz out, so right on the money. Let's take ourselves up to mid-band again, about 1700. It will be 1.7 megacycles. I call it right about there. Here's our signal. And we are 1717. So we're 17 out of 1700 off. So very small amount. Alright, let's take her up to 3.2 megacycles. Right about there. There's our signal. Let's go up another range just so it's easier to see. And 3182.6, 3183 instead of 32. So 18 out of 3200. Very small percentage. Next band. Now I want to mention this kind of a generator does a lot with a little. So one of the things pretty standard about the generator is that as you change your frequency and your ranges, you're going to see the amplitude change greatly. You're a lot more efficient in certain ranges than you are at others. And that's one of the reasons why you have the attenuation controls, and you will notice that there is a difference on the amplitude of the dial. Alright, so right now we should be reading on the inner band 3.1 to 11 megacycles. So this is the second dial in. So we should be 3.1 right now. There's our signal. And we are reading 3.1028. So just about perfect. Mid-band. So it would be about 5.5 megacycles. I'm going to say she's right about there. Signal looks good. And we are running 5.543. So 43 out of 5,500. If we were 55, it'd be 1%, I believe. So we're doing good. All right, in full scale, right about there, I'm guessing. There's our signal. Again, let's go up. Looking good. And we are supposed to be reading 11 megacycles, or 1100, and we are reading 10,780. So we are 20 out of 11,000 off. Very, very small percentage. So we're right on the money pretty much. Next band. Yeah, we're where it's going to get a little tricky, I think, here in the next band for amplitude. So what I'm going to do is I'm going to change my scope to just one down for a little bit more sensitivity. Make sure we're up full. There we go. And we want to go from 10 to 32. So once again, we're on the outer dial. Okay. And we want to read 10 megacycles. There's our signal, looking nice. And we are reading 10,039.7. So let's call it 10,040. So we're 40 out of 10,000 off. Very small error. And go to mid-range. About 17 again on the dial. And we should be reading 17 megacycles. Signal's looking good. We are reading 17,179.7, so call it 17,180. Alright, so that would mean we are 179 out of 17,000 off. So about 1%, I believe. And 32 on the dial, right about, oh, I'd say there. Alright, here's our signal. And look at our counter here. We are reading, should be reading 32 megacycles, we're reading 31 and a half. So we're off a half of a megacycle. So that'd be 520 out of 31,000. Alright, and then we go to the last band. This is F. On this one we use the innermost dial, 32 megacycles. At this range, you do not want to have your frequency counter attached. In fact, you want to try and keep your cables as minimal as possible to keep the capacitance down and keep your losses down. You don't want to give any other alternate paths. So we're at 32 megacycles on band F. This is our weakest end of the range up until about mid-scale. Right now we're pushing out about 20 millivolts peak to peak. Signal looks good. I'm not going to even try and show you the frequency counter yet. We'll do that in a moment, individually. But let's go ahead and check mid-band. Oh, yeah, let's go ahead and show you what happens to the signal as we're going up. As we go up, we see the amplitude change. Picking up amplitude, we're getting up into the mid-range area. I'm going to call mid-range here 60. And I'm on 60 on the dial right about now. Change my range up a little bit here so we can see the whole thing, and let's increase our range swing. So there's the signal. At 60, and then we're going to go to 110. I think that's it right about there. And we are off the scale, so we've got to go up a little bit, a little less sensitivity. We're putting out a big signal here. That's our signal at 110 megacycles. Looking good. And then let's go ahead now. We're going to move our cable to the counter. Alright, we are supposed to read 110 megacycles here. Right now we're reading 114, so we're 14 out of 110 off. Actually, we're 4 out of 110 off. Try that again. So, you know, somewhere 2-3% maybe. This is our toughest range to work with here. Let's go ahead and bring ourselves back down to that 60 that we had a few moments ago. Looks like right about there. And we're seeing 61.2. So let's say 1.2 out of 60. And okay, so I don't have enough signal strength below 45 to actually push the frequency counter. Counter's not sensitive enough, so even though we'll be able to use it as a signal for a radio just fine, just not enough output to push it. So we got enough to see the trace on the screen. Okay, at this point I'd like to demonstrate the internal and external modulation. If I'm on external modulation, that means I don't have a modulator connected right now at all, in which case I see the continuous waveform like you would right there. And if we go to internal modulation, just turning the dial like that, then I get a modulated waveform. So now if you watch the waveform, here's continuous wave, modulated. That modulation allows you to hear a sound over your AM radio. Without it, you just hear maybe a whoosh of the station coming in, but it'd be silent when you got there. So this gives you something to listen for and an amplitude to try and gauge a signal off of if you're trying to adjust IF stages or whatever. So that demonstrates that the modulation is working. While we're at it, let's give the attenuation a turn here. We're in the high level right now. We're going to medium, and I'm going to have to turn my scale up now so that you can see that the attenuator worked. And then here's low, and I really got to push it now. But it's good to have that attenuation because you want to try and feed a signal to your radio when you're adjusting it that's as low a level as you can take. All right, this is a beautiful little unit, very clean, sharp looking, functions beautifully. Dial is calibrated well, and the output looks very good across the entire range. I will provide a manual with it, and I'll provide a manual and a set of gator clipped coax connectors with it. So I'll start you out with the entire kit, and wish you well. Thanks for listening. We'll see you again. Good night.